This is AQA GCSE chemistry, and it is triple only. So if you're taking dual award, you do not need to be concerned about what is in this video. You can disregard it. As always, I'm going to recommend that you have a go at the activities, pausing the video as you go, and that's going to allow you to see where you're making progress and where perhaps you need to pay a little more attention to get to where you want to be. So in this particular video, we're going to take a look at percentage yield of a calculation, or percentage yield of a reaction, and doing those calculations. And we have got a fairly straightforward calculation to do. Percentage yield is the actual mass of product produced divided by the maximum theoretical mass, and we multiply that by 100 to get to the percentage. Now, what you will often find is that this will be combined with a reacting masses question. Reacting masses were done a couple of videos ago, and this table will hopefully be quite familiar to you. So you'll notice that we've got 1,000 kilograms of limestone, and we made 420 kilograms of calcium oxide. Don't fall into the trap of putting that 420 in. That's what we actually made. We need to calculate what we should have made. So my 1,000, I then put in my 100 and my 56 as my MRs. From here, I can work out there are 10 moles of calcium carbonate. From a 1-to-1 mole ratio, I know that I'm making 1 mole of calcium oxide, which means a mass of 560 kilograms. The actual percentage yield calculation is the tiny bit that follows, because the question told us that we made 420, but we should have made 560. So I take my actual mass, divide by my maximum theoretical mass, multiply by 100, and it comes to 75%. So let's have a go at this example. And I'm going to start by drawing out the table. I've got my magnesium carbonate and my magnesium oxide as the two things I'm interested in. I started with 168 grams of magnesium carbonate. I put my two MRs in, 84 and 40. From there, I can work out my number of moles of magnesium carbonate. There are 2. And my mole ratio from the equation, 1 mole of magnesium carbonate makes 1 mole of magnesium oxide, 1-to-1. So if 1 mole makes 1 mole, 2 moles will make 2 moles, and I now have N and MR that I can multiply together to get my maximum theoretical mass yield, 80 grams. I didn't make 80 grams, I only made 60 grams. So I do 60 divided by 80, multiplied by 100, and I get 75%. Here's another example for you to try. And once again, we draw out the table. I've got my Mg and my MgO as the two species I'm interested in. I am starting with 72 grams of magnesium. I put my two MRs in, well, AR and MR, and then I can work out my moles of magnesium. My mole ratio here is 2-to-2. So if 2 moles makes 2 moles, 3 moles makes 3 moles. 3 multiplied by 40 gives me a maximum theoretical yield of 120 grams. But we didn't make 120 grams, we only made 80. So I do 80 divided by 120 multiplied by 100, giving me a percentage yield of 67%. Another example for you. So I draw out the table. Once again, I can put my 9 or my 2.1 grams of lithium in. I put my atomic mass of lithium and molecular mass of lithium chloride into there. And from there, I can work out my moles of lithium. 2.1 over 7 is 0.3. And then the ratio is 2-to-2 or 1-to-1. If 2 moles makes 2 moles, 0.3 moles makes 0.3 moles. Multiply my N and my MR together, I get 12.7 grams. Now, I should have made 12.75 grams, theoretically, but I only made 9. So 9 divided by 12.75 multiplied by 100, I get a percentage yield of 70.6%. Next example. And the table gets drawn out with the two species, my 20 grams of sodium hydroxide, my MRs go in, I do my mole calculation, my mole ratio. From my mole ratio, I can work out the number of moles of sodium chloride I should have made. I can multiply those together, I get 29.25 grams. 29.25 grams theoretical mass I only made 22. So 22 divided by 29.25 multiplied by 100 gives me 75.2%. Now, there are many, many reasons why you might not get 100% yield. Have a go at thinking about what those reasons might be, and I'm going to list some in a moment. While there are many, many clues on this page, it might be that the reaction is reversible. You learn about reversible reactions in a later topic, or if this is revision, you will be familiar with them, but that means you will not get 100% yield because the product converts to reactants. It might be that there are impurities. If there's something in there that shouldn't be, that won't react and we won't get the product we would expect. We might also lose product to the environment. We might get gas escaping into the atmosphere. Liquids might spit, for example. It might be the reaction hasn't gone to completion. You've simply not left it for long enough. So only part of the reaction has taken place and there are still some reactants present. And it might be that there's an alternative reaction occurring alongside the one that we wanted to happen. So a whistle-stop tour of percentage yield. You will be familiar with this from a required practical as well. Calculating percentage yield. Generally, that's with the combustion of magnesium to make magnesium oxide. But that takes us to the end of this video. Thank you for listening and goodbye.